Hi, welcome back to Mr. Slover's Math. Today we're going to talk about the product rule of exponents. So the warm-up is getting us ready for that. It says simplify the following. So 2 squared, and I wrote down in red what all of these mean. 2 squared means 2 times 2, which is 4. 6 squared is 36. 4 cubed, which is 4 times 4 times 4 is 64. And then 3 to the first is 3. So be careful when you're using your calculator or when you're reading through this. 2 squared is not 2 times 2. Or sorry, let's try a different example. 6 squared is not 6 times 2. 6 squared is 6 times 6. Just like letter C, 4 cubed is not 4 times 3. It's 4 times 4 times 4. So please take your time and make sure you're understanding what it's meaning. Number 2 is asking you to simplify, so you're just multiplying this out. If there's no operation between these parentheses, it's assumed that it is multiplication. So I multiply the two numbers together, multiply the two numbers together, multiply the two numbers together, and same thing on the last one. And then the last warm-up question says, what's the difference between 3x and x cubed? Well, 3x is saying 3 times x. Whereas x cubed is x times x times x. It's itself 3 times. So there was our warm-up getting us ready for what we're doing today. There is a little bit of vocabulary that we need to learn before we get into the lesson. So the coefficient is the 6, is the number I highlighted in yellow. That is the number in front of your variable. The variable is your base. So in this case, the base is highlighted in blue, and it is x. And then the smaller printed number, not the smaller number, the smaller printed number is your exponent or your power. And you've seen your exponent or your power before. We've talked about coefficient, but we may not have talked about a base. So once again, the 6 is the coefficient. It's the number in front of the variable. The variable in this case is your base, and then your exponent or your power is the 4. So this chart was to get us ready for learning and discovering the rule for what we're going to do today. So the product rule, I'm going to take 2 squared and I'm going to multiply that by 2 cubed. So if I were to write that all out, if I were to expand it out, I just called it repeated multiplication. If I were to expand it out, it's 2 times 2 times 2 times 2 times 2. And I end up with 2 to the 5th. Now I can do the same thing for all these other ones, and I chose to use the colors to coordinate what information went with what. So 3 to the 4th times 3 to the 5th. So I've got 4 of these 3's, and then I have 5 of these 3's. And if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 of them. And I do the same thing with the 11s and the 5s, and I can do the same thing with variables. X squared is x times x, and x cubed is x times x times x. There's 1, 2, 3, 4, 5 of them, x to the 5th. Now here, x is my base, just like it was in my example up here. But in all of the other ones, my base is a number, and that's okay. So my base in this one is a 2. My base is a 3. My base is an 11. My base is a 5. So your base does not always have to be a variable. I want to point that out while I have this example. If you're like me, you don't want to write everything out. There's got to be an easier way. So how do you think that we went from this 3 to the 4th times 3 to the 5th and ended up with 3 to the 9th? Or 11 squared times 11 cubed, and we got 11 to the 5th. Or x squared times x cubed and got x to the 5th. I wonder what we did. Well, maybe you figured out that we're just adding. So when multiplying the same base, which is typically the same letter, or it could be the same number, you are going to add the exponents. And if there are coefficients, you multiply them. So let's backtrack up here. If I added 3 plus 4, did I get 9? If I added 2 plus 3, did I get 5? If I added 2 plus 3, remember there's no power printed there, but it's a 1. If I added that 1, do I get 6? 2 plus 3, do I get 5? Yeah. All right, so the rest is just examples of this. Simplify each expression. They have the same base, an h and an h, so I can add my powers. 7 plus 2 is 9, h to the 9th. Notice this note in red on this one. If no power is printed, assume it's a 1. So I'm putting a 1 there. And the reason I'm doing that is to make sure I add my powers correctly. I have 5 here and 1 here. That makes a total of 6. Same base, I can add them together. Letter C, same thing. I have the same base, a D and a D. I add them together. I get 10. 8 plus 2 is 10. Letter G, these are not the same base. They're not the same letter. So I can't do anything with them. I leave them alone. I don't leave it blank. That means to Mr. Slover that you skipped it. That's not true. Okay. Example 2 and 3 are just getting a little bit more complex on what we're doing. So now I've got an X and an H. So remember, in order to combine or to multiply those together and add our powers, they have to be the same base, meaning the same letter. So I underline the H and the H. Those two can go together because they're the same letter. 7 plus 2 is 9. There were no other X's, so it stayed as an X squared. I go to letter B, W squared and W. I have my power is 3. There's a 2 there, and there's that imaginary 1 there. So I add 2 plus 1, and I get the 3. Then I look at the Y's. They're the same letter, the same base. So 5 and 1 gives me a 6. Same thing on C and D. I tried to circle, identify my like bases. And then you add those powers together. And example 3 is the same concept, but now I'm adding coefficients. So I'm multiplying my coefficient, 4 times 3 to get 12. And then I have the same base, H and H. I add those powers. 1 plus 2 is 3. Same thing on letter B. Multiply your coefficients, negative 2 times 78. And because these are the same base, the same letter, I can add them together. 2 plus 4 is 6. Now letter C, it doesn't matter that this says 16e times 4d to the 7th. It doesn't matter that the letters are not the same. You can still multiply your coefficients together. So we're still going to multiply 16 times 4 to get 64. But we just don't do anything with the e and the d to the 7th because there's no other e's and there's no other d's. So they stay exactly what they were. We just write it as that answer. So D, E, and F are all very similar. If there's coefficients, you're multiplying them. And then if your bases are the same, or if you have the same letter, you can add your powers. Okay? Because all of this is multiplication. So to recap, when you are multiplying, which is what we did today, that's all we did. We multiplied in all 3 examples. And your base is the same letter. That's mostly what we focused on, the same letter. You can add your exponents together. And if you had coefficients,